Okay, so what we're looking at today is we're going to learn about a very, very important physical law. And what we're going to start with is this track right here. And what I'm going to ask you to do is I'm going to ask you to make a prediction, okay? And that prediction is this. What I'm going to do is I'm going to take a steel ball, this marble here, and I'm going to roll it down each of these 4 tracks. Now you'll notice that the tracks all start at the same height and end at the same height, but they have different profiles. So the blue track has a particular profile where it seems to go flat for a while and then come down. The yellow track has a different profile, it looks like it's just going straight down. And the green track goes down kind of gradually. And the red track at the back, you can see here, drops quickly here and then comes across in a more flat fashion. Now, the key is this. What I would like you to predict, and write this down on your sheet, okay, is I would like you to predict that if I roll this marble from the top here and release it from rest on each of them, okay, so it's going to start from rest and then roll. What I would like you to do is predict which profile will have the ball leaving at the fastest speed. So I don't mean how long it takes the marble to get from here to the end for each of the ramps, because that's probably going to vary. But what I want to talk about is what's the speed it's going to leave the ramp at. So down here, how fast is it going at this point? And how we're going to measure that is, you think, well, how would we be able to measure that? Well, what we're going to do is we're going to use a ruler, and I'm going to place that ruler on the floor, and I'll use one of the tracks first, and I'll roll it, and I'll get it to the point where the ball lands on it. And then what we'll be able to do is look at the other profiles and see where the ball lands in relation to that one that we pick. And that will give us an idea of how fast they're going relative to each other. So we can figure out which one's the fastest, produces the fastest rolling marble or falling marble, and the slowest rolling marble. So what I'd like you to do now is I'm going to pause the video. You're going to make a prediction. You're going to either say B for blue being the fastest, yellow being the fastest, green, or red. So you get a little bit of time to think about it. So you're going to do that now. Okay, so now that you've made your prediction, what we're going to do is actually do this little experiment. So I've got the meter stick, I've put it on the ground, and what I'm going to do is roll it down one of the ramps, and I'll actually point this down at the floor, I think, so you can see it. And I'll move this over here so we can see both. Okay, so what we've got, there's the end of the ramp, and we're going to see if we can get this to work. All right, so I'm going to roll it down the blue one. All right, so it looks like it hit around here. So I just got to find the first one and get it just right. There, I can see the dents in the floor. Perfect. All right, so now I've got it. So if I roll it, it should hit it nicely. Okay, perfect. So we hit it, and now I'm going to try the other one. So that was blue. So if you picked blue, now I'm going to roll it down the yellow. When I roll it down the yellow, we're going to see where it lands. Oh. Landed right on it. So wait a second. The blue came down, landed there. The yellow came down, it landed in the same spot, meaning it's probably going the same speed. Look at that. Right there. I can see the dent from the blue, the yellow, now the dent from the green. By now you've probably thought, I should probably change my prediction. Because if I drop it from the red, there's the red dent. Perfectly on the ruler. Meaning that regardless of the profile, this ball leaves the ramp at the same speed regardless of the profile. Okay? So why is that? Well, this is the law of conservation of energy. And what it says is basically that if we do work to get the ball to this height and have it at rest, when it's at rest, it has no kinetic energy. It just is all potential energy. Now, as it falls, it gains kinetic energy as it loses potential energy. Well, it only had this much stored energy at the top, which means that it converted it to kinetic energy at this point, and that kinetic energy is related to its speed. Well, the yellow track, it has the same amount of gravitational potential energy because it's at the same height. And because it changes height by the same amount, it will convert the same amount of potential energy into kinetic energy. And as a result, since kinetic energy is related to the speed of the object and the mass hasn't changed, therefore this object will leave the ramp at the same speed. And that's the same for the green and the red. The law of conservation of energy is a very, very important law to understand and to learn, since it is the fundamental conservation law in the universe.